This talk today is going to be talking about approaches to writing secure C++ code, or more so taking the code you already have and trying to improve the security of it. I'm Pete Freitag. I have a company called Foundation, which is one of the sponsors here of the ColdFusion Summit. The type of work I do there ranges from consulting, which would be like code reviews or server reviews, down to development. And then I do a lot of product development as well. A couple of security products. We have FuseGuard, which is a web application firewall for CFML. PackMyCF is a server scanner that checks the configuration of your server for security issues. And the latest product is called Fixinator, which is a code security scanner. So I still blog at petefreitag.com, and just in case you're wondering, I'll post these slides to my blog, as well as sometimes the conference does a big slideshare thing with everything, but for sure you'll be able to get in there after the conference. Okay, so a couple of recent headlines this year. Most of them are even fairly recent. DoorDash, 4.9 million customer records breached. Facebook, 600 million passwords stored in plain text. Dunkin' Donuts had credential stuffing attack. And that's where attackers just try a username and password that they know worked on another site that was breached, and then they try to attack other sites with that same password. And so one article estimated that 4.1 billion records were already breached. Customer records were already breached in the first half of 2019. That's basically like half the planet. So what that boils down to, and one about the iPad there is also a true story. So what that boils down to is that pretty much everybody in this room has probably been impacted by a data breach, has had their stuff impacted. So it hits close to home for everybody, I think. And then the other thing I take away from that is that even the biggest, wealthiest companies in the world, like Facebook, Google, Apple, that have trillions of dollars and hire the best developers in the world, they still have a lot of security issues too. So it's a problem that is common to every single person that's doing software development. So we can't ignore it, and we don't also at the same time want to feel like we're special and that we write code that doesn't have security vulnerabilities in it. That's going to be the case for everybody. So don't feel bad if your code has security issues in it. It's going to happen. It's just part of development, just like getting a bug in your code. It's going to have security issues. So, how many of you here have to work with an old, large code base? The vast majority. So, these old, mature code bases have thousands of lines of thousands of files typically. I've seen code bases with like 20,000 files. Anybody have that many? Get them? Yeah. Which is a lot of code, right? It has a lot of code that you hope you never have to look at ever again, or for any reason whatsoever. And it can take weeks, but often months, or even years to properly secure such a large code base. So that kind of makes it a little bit intimidating to want to tackle this problem. So in this talk, I'm going to try to give you some ideas of ways to get started, even with if you already have a full schedule and you're not going to dedicate an entire team of people to working on it. The other thing is the code base probably uses outdated technologies, and it can be sometimes hard to fix. Brittle. You might be afraid to actually try and fix it because you're afraid of what's going to break. So these are all challenges that you're going to face when securing a legacy code base. So a couple different general approaches you could take. You could go in all-out security mode and go crazy, fixing stuff for months on end. That's going to work really well, but it's also going to mean that you're not going to be able to do anything else during that time. So, and that's typically not going to happen, but there is one time when this happens, and that's when you actually get breached, and then everybody goes into this mode. So it's much better to take one of these more gradual approaches, if you can, and continually work on improving the security. So another thing you can do is prioritize, spend some time looking at where vulnerabilities might be in your application, and spend a little bit of time focusing on each of those areas at different points in time. And then the third option, which I think works pretty well in general for people who are already very busy, already have lots on their plate, is just as you're going, as you're developing, be aware of what security issues are, and then when you see them in the code, don't just close your eyes and scroll by them. Actually try and fix them while you're working on a chunk of code, so that you're continually improving the security in that way as you're doing your regular day-to-day work. And then the fourth option is you could also hire somebody to fix issues for you, which works well when you're busy too. So step one, delete all your code. No, not all your code. So you might have a lot of code that never actually runs, right? You have code that you wrote back in like 2007 that was for some specific thing you did in 2007, or your organization did in 2007, and that code is still sitting there somewhere in a folder, even though it's no longer used. Stuff like that. This old code is often full of security holes because it was used with outdated techniques, but it could still be discovered by the attacker and exploited. So you might have homemade version control. Does this look familiar to anybody? EQUIFAX_2, one of my favorites. Now, do you think it's very hard for an attacker to crack that code of index _2 or like index _old? No, they could easily find that. Those files are still there. They're still executable on your server. So what you want to do is get rid of them as best you can. So when you have homemade version control and no actual version control, it's a little bit scary to go and just start deleting code, right? So a good first step is to make sure that you are actually using proper version control. So that could be Git, it could be Subversion, it could be another type of version control, but using some sort of version control is a pretty essential step because that keeps a backup of all your code, all the changes you have on your code. And what's more is that let's say an attacker did get on your server and altered files slightly, how would you know? Could you compare that to like a single source of truth, which would be your source control repository, where it shows each developer which changes they've made. So it's very useful from that point of view as well. So, spend some time to identify this unused code, delete it. Version control's got your back. So, if you delete something from version control and realize that, oops, I needed that, you can go back and find it and put it back into the repository because it has a backup of the entire history of the code. So, there's a lot of fads that you come across in software development, but version control is definitely not one of them. It's been around for a long time. It's a solid technique. I'm not going to go into too much detail here, but here's a couple commands you could run to look for old files on your computer or servers. I won't go into the details of it, but I'll grab the slides and try to do that. Here's another one for another way to look for it. Okay. So another good initial step is to make sure that your servers are fully patched and don't contain vulnerabilities in them. So that means you need to be using ColdFusion 2016 or greater. ColdFusion 11 and below have all reached end of life, and especially with this last security update, I believe ColdFusion 11 is probably still vulnerable to at least one of those issues, but there's no patch for it because it's reached end of life. So if you're still running on those older versions, it's definitely time to update. Same with operating systems. Windows 2008 is end of life. And finally, the version of Java that we're using. So you want to make sure you're using at least Java 8 or above, and you want to keep the version of Java updated as well. Every quarter, Oracle updates Java with security updates. So just a couple examples of different vulnerabilities that would actually be solved just by making sure your servers are patched and updated. So like, for example, one of them that's interesting is the TLS SSL protocol implementations. So if you're using an older version of ColdFusion, you might really have to start having trouble doing CF HTTP calls to sites that use SSL because it's trying to use these old obsolete protocols that are no longer supported by a lot of servers. So stuff like that, it's really important to keep updated. So a couple other things that kind of like are small changes but can really drastically improve the security of your code base would be to make sure that you're not running ColdFusion as the administrator, user, root user, or local system service. So you can run ColdFusion as a dedicated user account. Then from there, the ColdFusion user really only needs permission to read your CFM files. It doesn't have to write to the web root unless you're specifically doing like a CF file or file writing type of operation and you're writing files somewhere. So you can kind of pare that down quite a bit. All right. So this particular survey of enterprises found that nearly 60% of all breaches were due to unpatched vulnerabilities. And that would pretty much line up with what I've seen out in the field as well. So let's take a look at one such breach. The EQUIFAX breach, which happened, I guess it was in 2017 now. So that whole breach, which got a lot of attention, I think even a congressional hearing, that was caused by using a vulnerable Java library in one of their applications. So it's called Struts, the library. So the Struts library was patched in March 7th, and EQUIFAX discovered the breach on July 29th. And then guess what? They patched the next day. Did I tell you, like, you go into crazy mode once something gets breached? So you don't want to be in that mode as much as possible. You want to avoid that. So you can see here, it didn't take that long for this vulnerability to be exploited by hackers, right? It was disclosed in March, and just a couple months later, already breached. All right, so this is actually interesting, is that a year later, somebody did some research and found that as many as 10,000 organizations, including 57% of the Fortune Global 100, after the EQUIFAX breach happened, had downloaded that same vulnerable version of Apache Struts. So, are we learning from our mistakes as developers? Not really. Not very well. So this just kind of goes to show that using vulnerabilities, known vulnerabilities, vulnerable components, vulnerable third-party code is really can be really dangerous because while the attacker can craft an exploit that's going to work on a lot of different places in these scenarios. So some third-party tools you can use to do this. The Fix Standard tool my company makes will actually look for vulnerabilities in ColdFusion third-party components. So like, if you remember, for example, like the executor file upload issue back in like the 2000 CF8 days, it'll look for stuff like that. Old custom tags that have vulnerabilities in it. Things like that. It also looks at jar files like Java libraries and JavaScript files for known vulnerabilities in those as well. A couple other tools that are open source: OWASP dependency check, Retired.js, and the NPM audit used to look for various vulnerable components. So really, what you do is you find these vulnerable components, and then you just probably need to do an update of whatever piece of code it is to the patched version, and then you've eliminated a big risk to your application once you've done that. So the problem here is that, let's say you decide to do this, when you get back to work next week, and you do it, and you're not using any known vulnerable components, but a month later you are. a new vulnerability comes up, and now you do have a notable component. Unless you're actually scanning your code like every day, you're probably not going to realize that. So that's where the idea of continuous security comes in, where you can take advantage of some new technologies to take care of that. The first thing you need to be able to do this continuous security is you need to have some sort of version control. So it could be Git, some sort of Git repository, it could be GitHub, Bitbucket, GitLab. If you're totally new to it, GitLab is actually pretty cool because it has the version control, but it also has a lot of other stuff in there, all built into it. These can, both GitHub and GitLab have an enterprise version that can run on-premise, or they have hosted versions that run in the cloud. So, next thing you need to do is learn yet another markup language. That's seriously what it's called, yet another markup language. Yeah, you don't really need to learn it so much as you're gonna end up using it. So YAML looks like this. This is an example of a YAML script, and it's really just giving you a couple commands that are going to be run. And so pretty much any of these CI platforms, these are called continuous integration platforms, will end up using some sort of YAML file that you'll fill out and tell it what to do. So the way it works is like this. So all the way on the left there, the developer writes some code, commits the code to their source code repository. So that's where the little GitHub icon is, the next step here. Now, when GitHub receives that source code commit, they fire off a webhook event to your continuous integration tool. Your continuous integration tool will basically just executes this script, okay? And that script is going to invoke whatever security tools you want to use to scan the code. So you can use Fixinator, you can use a dependency check, OS dependency check. You could use any number of tools, and you can use multiple tools, all within the same check. And then from there, what's important is that the developer gets that feedback loop pretty much immediate, not immediately, but pretty quickly. So let me just show you how this works real quick with an example. All right, I got a repository here, which right now it's got a failed issue. This is on Azure DevOps, and this is what their continuous integration pipeline looks like. So basically, what happens is I scanned the code and it came up with you've got an SQL injection vulnerability in the code. Right here. On line 3 of use.statement. So let me show the code here. So this is my code, this is the issue. I can actually use Fixinator to and I can tell Fixinator that I actually want to fix this issue, and actually just fix it for me. There. And then from there, I'm just going to commit this to my source code repository. So I'm committing that to GitHub, pushing it from GitHub. And what that's going to do is it's going to create a new pipeline request here, right here. See that's that commit I just did. It's already working on it. It's going to bring up a new, basically like a Docker image where it's going to run the scan here. So that's kind of how it works. I'll let that go. We'll come back and check on that in a second. This is, and like I said, this is what the script looks like. In general, it's going to be a little bit different depending on which CI platform you use. So scripts will look different for each one. But essentially what we're doing is we're installing some software in that before script section. And then in that script section, we're just running the software. And then it executes and produces a report. So the Azure DevOps, we just saw, here's another example of GitLab. This is what their pipelines look like that execute these tests in your code. There's a security tab. So I built this in such a way where I'm actually able to produce these reports and put them right into GitLab UI so that you can see them right here, and then you can click on and get all the details of the issue, as well as the suggested solution. Let's see here. Okay, so this is there's a term in DevOps that they call shifting left. So this is one thing you can do to, when you add stuff to your continuous integration pipeline, you're able to shift left, meaning you're allowing the developer to be more flexible in how they're dealing with an issue. So in this case, it's a security issue. So how many of you have like code scans that happen on your code base at some interval? So maybe like half of you.
You mean a crawler?
It could be anything, yeah. Yeah, like a pen test, or it could be maybe a code scan during your test. All right. How many of you have that happen every time you commit your code versus you do it like once a year or once every 6 months, or like at some random interval you have to call up some security guy and you run the test and then you wait 3 weeks to get the report, then you have to fix all the issues. So when you have like a continuous integration thing going, you're going to get that feedback as a developer immediately. And you can see, all right, I need to fix this, and I know the code because I just wrote it, and I can fix it really quickly. So it really improves your productivity and your ability to handle security issues. So if you're interested in getting started with CI, here's a couple more resources. Michael Bourne has a course called 5 Days of CI with ColdFusion and Bitbucket. It's at learncf.teachable.com. There's a bunch of guides with Fixinator that in the documentation that will tell you how to set up CI on GitLab, Bitbucket, Travis CI, Azure DevOps, AWS Code Build, Circle CI, and Jenkins. And really, it's the same process. It's just like that YAML file looks a little bit different each time. Each of these platforms have their own unique format. It's not standardized. Okay. Other things you can do that's an easy, like low-hanging fruit thing to improve security is implement some sort of web application firewall. This kind of buys you a little bit of time as you're working on fixing your code base, because it can look at requests coming in, look for malicious patterns, and then just block those. There's all different types of WAFs out there. So once you've kind of done some of these global things, then you can start identifying maybe some high-risk vulnerabilities within your code. So I like to start with stuff like this. Things like file uploads is one of the first places I would look for issues, because there's a lot of ways that file uploads can go wrong. Remote code execution, and we'll talk a little bit about what that looks like and see it come out. Or dynamic evaluation issues. SQL injection, still one of the most popular types of vulnerabilities. It's fairly easy to fix it with ColdFusion, but it takes work and it takes attention. As well as file system access, path traversals, which we'll look at each of these in a little bit of detail here. So basically what I'm talking about here is anything that's going to compromise the server is where I would start. So there's, two different types of vulnerabilities. Some of them are going to compromise your server directly. So it's like when there's an SQL injection attack, and somebody deletes your entire database. That's kind of affecting the entire server and the operations directly. There's other types of vulnerabilities like cross-site scripting or request forgery or session hijacking, which kind of compromises the users that are using your app, more on the client side. So they're both important, but I like to start on the ones that compromise the server, because if you have any of those on the left, you can create your own version of anything on the right, basically. That works. All right, so let's take a look at what remote code execution might look like. So, in old ColdFusion code, you'll often find that there is this evaluate function in there. The main reason it's in there, especially, was back in like ColdFusion 4.5 and lower. The things like the form struct was not actually a structure. It was, so if you wanted to access form.checkbox3, you had to use the evaluate function in order to do that. So as of like ColdFusion 5 and above, it's part of the structure, that you can use the structure function. There's structure notation to access those values dynamically, but that wasn't possible back then. So you see a lot of evaluate things on. Take a look at an example. So I've got, this is just, this application here, Bank of Insecurity, is an application I used for the training yesterday. I did a full-blown, full-day training class on security. And this application is basically just full of every type of vulnerability you can imagine. So right here, I'm just looking at a news story. And if I change this to ID equals Z, I get an exception. And then my error handler comes up. So part of my error handler, I have this like handy debugging information being output here. And you know, obviously you wouldn't want to display that sort of thing to a user, but maybe, you know, you might ship that stuff off to an email or something like that to notify somebody. So let's look at the code. Right here. So we've got this evaluate function here. We're looping through each of the keys of the URL struct. We're calling evaluate URL.key. Right, so the evaluate function, whatever gets passed into it, is basically can be a ColdFusion expression, right? So I could pass in, you know, 6 plus 7, and it would evaluate that dynamically. Or I could pass in URL.x plus URL.y, and it would give the answer to that with evaluate, because it's actually evaluating the code dynamically. So what the attacker could do is modify the query string a little bit here. So now I'm going to create a URL. So I just look at this ID equals Z, which is just there kind of to trigger my error handler here. Now I've got, and it's a little bit difficult to read the other part here, but I've got ID dot list append, and then in parentheses get tick count. So what is get tick count going to output? Some sort of number, right? Like the number of milliseconds since epoch. So if you look at my handy debugging information now, you see I've got this value here equals Z comma, and then this big number, right? It's because I said that my variable name was id.listAppend, so the ID value is Z, so I'm appending to Z the value to get the tick count here. So you're not going to do anything with that. I could write any CFML code. Basically, I want at this point. I can call any function So it's a remote code execution. So I can use like get. Right, and so now I'm getting the full file system path here. I can call file delete template path and actually go ahead and delete that file. So there's a lot you could do here. This is all just from the address bar that we're doing on this. We're not using any fancy hacking tools. Just coming right through the URL. So, to fix the evaluate issues, you want to rewrite them, remove the evaluate function, and typically you can use the bracket notation instead. So in this case here, I could rewrite this as URL key. And these are roughly equivalent, except for the fact that the one on the right here is vulnerable, the one on the left is not vulnerable. But functionally, they do the same thing. The evaluate one just does a little bit extra than the one. Okay, so to find these issues, you want to search your code base for the evaluate function. In most cases, you don't need to use evaluate at all. You could fix it with the bracket notation. Now, if it happened to be like a query and you were referencing a column name within that query dynamically, you can see there's an example of query name, bracket row, and then bracket column name notation. Not all the cases of evaluate are going to be super easy to fix, but what you want to do is make sure that there's nothing, if you do have evaluate in your code, you want to make sure that there's nothing coming in that's untrusted as a variable into that expression. If you're just doing evaluate 5 plus 7, I don't know why you would do that, but that's not necessarily helpful. So also look at the precision evaluate function as well, because that has the same properties. And then there are actually other functions of evaluate dynamically. Does anybody know? Okay. Yeah. So the IF function is also a function that evaluates dynamically. So the second and the third arguments there are treated the same way as evaluate would be. So it's going to actually execute whatever's passed into it as an expression. So even with using that DE, the delayed evaluation function, it's still possible to have remote code execution. You can have that DE in there as long as some sort of variable is going in there. If the values of the second and third argument are just both hard-coded strings, then that's not vulnerable. But if you have any sort of variable going in and it's untrusted, then it's going to be vulnerable. Let's take a quick look at an example of that. So, alright, so right here, this is where the messages are displayed when somebody contacts the bank. So if I do repeat task, it's going to show up here. If I contact and I skip my name, it's coded to say anonymous instead of just an empty string. So in the way that's coded in this application, is using the inline if function right here. So it's either using the contact's name. It's pulling this out of the database after the form is submitted and displaying it. Right? So the problem arises if, let's say my name is Mr. Get Tick Count. See here that actually evaluate that because my name was passed into the second or third argument of the inline if function. And my name happened to have pound sign and CFML code in it, so it was executed. So, you want to avoid the inline if function in your code as well. How do you rewrite this? So, there's two ways to do it, depending on how your code works. But here, actually, there's more than two ways to do it. There's as many ways as you want. You could use an if statement as well, just use a CFF and else. But here's kind of like a one-liner example of how you do it. You can use the ternary operator, which is in CF9 and above, which basically just takes some sort of condition and then question mark, and then it returns the first part if it's true, and then the colon, the second part if it's false. And so the Elvis operator it's called the Elvis operator because it kind of looks like the Elvis smiley, if you turn your hand there. And what that does is it tests to see if URL.name is defined or not. Basically, it's not null. And if it's not defined, if URL.name is not defined, it would just return friend. Otherwise, it would return whatever value is in URL.name. So it's slightly different because it's not checking the length. That's the idea. All right. So file uploads. How many of you have file upload code in your applications? Pretty much everybody. So, very common. Yeah, it can be very dangerous if you don't pay attention to a couple things. The first rule of file uploads is to never trust the mind. What I mean by that is the mind code. So, ColdFusion 10 added this new feature called the strict attribute, which changes how this works a little bit. But essentially, before CF10, it would use the MIME type in the browser to determine what's allowed. And let me maybe go back here and show you the code. So assuming you have some code like this, and you've got this accept attribute with a bunch of MIME types, this is what I mean when I say don't trust the MIME. Don't trust this accept attribute with a bunch of MIME types as your only form of protection, because it's not sufficient. So, let me show you an example here. All right, so just create a little CFM file that does a CFHTTP, and what it does is I'm telling it that the MIME type of this file that I'm sending it is image/PNG, even though I'm actually sending them payload.cfm. So this would be an example where the client is sending a MIME type and ColdFusion's trusting it. And this is the behavior by default before CF9. So if I run this, you can see here. Oh, let me just delete this. Yesterday there. So there's no CFMs in photos right now. I'm going to run this upload hack. And now there is no CFM. Right, so payload.cfm. But I kind of cheated a little bit because, like I said, that's how it worked prior to ColdFusion 10, and hopefully most of you are on newer version. So on newer versions, it's more like this, so strict equals true. So if I try this now, this upload hack again, now I get an error saying, sorry, the MIME type of the extension of the uploaded file was not accepted by the server. Right, so, but do we trust MIME type still? No, right? We're still using MIME type here for this check. And how's it doing this? It's looking at the file contents to say, like, is this an image/JPEG or is it image/PNG? And the problem with that approach is that it's possible to create something that ColdFusion thinks is a PNG, but it also is actually just a CFN file with some CFML code in it. So, for example, if I change my payload to be a file I created called image.cfm, these are all things that attackers have actually done. Run upload hack again. So my image.cfm had a cfdump tag inside it, right? And you can see there that it just executed it because it's dumping out the server zero. All right, so what you should gather from all this is rule number 2, which is going to be, we always want to validate the file extension against some sort of list of allowed types. So ColdFusion 10 actually allows you to put file extensions in the accept attributes instead of the MIME type, which is a good idea, but we're not going to be quite that smart yet. So what we're going to do is we're just going to change this back to false. We kind of already showed it doesn't matter if it's true or false. We can still get around it. But just for the purposes of my demo here, it looks better if I do this. So let me try this upload hack again. So this time it says, sorry, invalid file extension, right? But if we look at the code here, this is where it did that, right? So it deleted the file I uploaded, and then it threw an exception saying, sorry, invalid file extension. So is it still possible here, though, to upload and execute a CFN file? We just uploaded it, and it actually was in the photos directory for just a couple milliseconds, maybe. So right here, there's like a very small window of opportunity where the attacker could execute that file. So if they're really lucky and they send a lot of requests, I have an example of here. So what I'm doing now is I'm doing this in multiple threads. In one thread, I'm uploading the server, or uploading the CFN file, and the other thread I'm trying to execute it on the CFN file. So if I try that, it worked. So it worked, and there's now a backdoor.cfn file on here. So, because what I did, which you probably didn't notice, is that the payload.cfn, when it gets executed, it writes another file called backdoor.cfn, which stayed after the payload.cfn was deleted. So rule number 3 is that we want to make sure that the destination of our upload is not into a web root, because it doesn't give you any, you don't have very much time, or any time really, to be able to validate the file so it's not one that you don't want on there, because the attacker could really quickly execute it before your code that checks the file and deletes it could run. So you always want to make sure that your upload destination is outside the web root. I usually just use like the get temp directory function, return to the temp directory, and you can upload in there and then copy it over once you're certain that it's valid. So even though we don't want to trust the MIME type completely, you could still use it as a check. You could expect file content using file get MIME type, as image file, as PDF file. Another approach is you can upload directly to a static content server instead of uploading to your own server. So for example, you can upload directly to S3, Amazon S3. But probably I think the best tip on here is to set up some sort of file extension whitelist on your web server. So if you're running Windows server with IIS, you can go to request filtering, and then go to the file extensions tab, and then so this photos directory that kept getting exploited here, right? Which was right here again. This photos directory, right? It shouldn't ever serve a CFM file, right? It doesn't need to. It only needs to serve JPEG and PNG files, stuff like that. So in IIS, we can go to request filtering, say allow JPEG, allow PNG under the file extensions tab, and then you click edit feature settings, and then there's a checkbox that says, I believe it's like allow unlisted file extensions. And if you uncheck that, then it makes it so that that directory can only serve JPEG or PNG files. So even if our code was written like this, which allowed the CFMs to be uploaded into this folder, we could have blocked it at a web server level. So they could, yes, they could upload a CFM, but they wouldn't be able to execute it because we blocked it in IIS. So that's a really good approach you can do. So if you have any folders where user photos are uploaded, or user PDFs or Excel files or whatever, Word docs, create a filter on your web servers to make sure that only those file types can be served in that directory. So back in the spring, the ColdFusion 2018 Update 3 and ColdFusion 2016 Update 10 and CF11 Update 18 added a new feature where, by default, it now blocks CFM files, JSP files, a big list of file extensions that might be executable on your server. You just want to make sure that you check that out. It's going to be in the ColdFusion Administrator. There's a list of file extensions. You're going to make sure that every file extension that's executable on your server, like if you have PHP installed or if you have something else that's maybe not standard, make sure that it's in that list as well. And that provides another layer of protection for these types of attacks. If your application doesn't allow uploads at all, you can go and set it to a star, which basically blocks all files uploads from working. You can also do this in the application.cfc using this .block.txt for file upload. All right, path traversals. So this is some vulnerable code for a path traversal. Essentially, we've got a CF include where the file name is a variable, and that variable, maybe it's a URL variable, which is not good, right? So let's take a look at the example here. All right, so we've got about page where it passes in page equals founder.html. here's the code. So it's pretty similar to that slide we just saw. Alright, so what we can do is do a path traversal tag now. So what we're doing is doing dot dot slash, dot dot slash, dot dot slash. And I'm going all the way up to this config folder that's actually above my web root, and it has this master password.txt file in it, which has the password to the database through anchor file. So using this technique, the attacker can basically read any file on the server that ColdFusion has read permission to. So that's where when you set up your file system permissions, it can make a difference. Now, you could also have a remote code execution attack via this. Let's see, today is 10:1, right? Right, so this is a log of all the requests we've been making to this application that we just pulled up, which can be useful for the attacker, especially if there's like a CFID or CF token in there, they take that and then plug it in and be authenticated as whatever user. So that's why you don't want to have CFID, CF token, or JSession ID in your URL. But beyond that, what the attacker can do is actually do a remote code execution attack via this. So what I'm going to do is make a HTTP request to the server, but I'm going to tell it my user agent is CFDump. And when I fetch that and reload this, you can see now it is dumping the server scope here. So, because the user agent contains the CFDump tag. So there's a little application CFC setting that you can use to prevent this. It's also in the ColdFusion administrator setting. And that's the compile ext for include setting. And so if I set this to CFM, it will make this remote code execution vulnerability no longer work, and it will just output CFDump instead of actually executing CFDump. Because what does the CF include do? It actually executes any code that gets included. That's why this was a remote code execution function. So with this setting here, I'm telling it you can only execute it if it's a CFM file. Otherwise, if it's just like a .log file, then it just treats it as just a static text file and it just includes the static. So it actually also has a performance benefit too, because if you're including stuff that's just maybe an HTML file, then it doesn't need to be evaluated as CFML. It will run fast. Alright, so to fix that, you want to avoid variables in your path names if possible. If you really need them in there, then you really need to validate them. So finding file access issues in the code is a little bit more complicated because there's a whole lot of different tags and functions you have to consider. There's like CF document, CF spreadsheet, CF module, CF include, CF file, and all the file functions, all the directory functions could all potentially be vulnerable. So any place you have a file system path in your code, you want to make sure that any variable in there is trusted. And if it's not trusted, you need to make sure it's validated and not going to contain any unexpected characters, such as the // or even like a null byte. Okay. SQL injection. So I know hopefully most of you are pretty familiar with this, but I want to cover it because I know it's always important to make sure that everybody's aware of this because it is one of the most common types of attacks and vulnerabilities out there. So this is what some vulnerable code looks like for SQL injection. We've just got this URL.id value in the query, and so what the attacker could do would be, for example, just do ID equals 0, semicolon, delete from news, and delete the entire table. or they can drop the table. It's not as simple as just, making sure that there's no semicolons in your values that are passed into the queries. There's a lot of other ways that SQL injection can happen without using multiple statements. But to fix it, we're going to use CF query parameter tag. So you notice I didn't add the CF SQL type. I don't necessarily recommend that you omit it, but as far as if we're just talking about security, in this case, that is all you need to fix it. So if you have like 16,000 queries that you need to fix, and you're trying to save some time, omitting the CF SQL type and using CF query parameter is still way better than not fixing it at all. So it might be, a good thing you can do at once is just add all these CF query parameters. Now, the one place where it might cause an issue is if the column was a date. And in those cases, then you do have to make sure that you specify the correct CF SQL type. If you're using query execute, the syntax for it is going to look a little bit different. You're going to do like a colon placeholder, and you pass in a structure with keys that match all your placeholders. So finding SQL injection, search the code base for all of your query stuff, CF query, query execute, or execute query. You can use static code analyzers, such as CF builder, Fixmeter, to find that for you. And this is also a good candidate for if you see one in your code while you're doing work, make sure you go ahead and fix these. All right, so the final step here is going to be, additional vulnerabilities. Like if you've covered all those critical ones, and you feel pretty good about that in your application, then you can start going on to some of the other types of vulnerabilities that could exist. Here's a few examples of those. Cross-site scripting, your session handling code, cross-site request forgeries, things like that. So there's kind of one of those topics where there's always more work to be done. You could always make it better, type of thing, but it can be overwhelming if you kind of think about your entire code like that. So I like to think about it. Let's start with really critical things and then work from there. Also, that bottom bullet there, OWASP.org, has a lot of good information about web application vulnerabilities. It's written not specific to any programming language, although it might have examples in different programming languages. But these vulnerabilities we're looking at are all, for the most part, not going to be specific to ColdFusion. They happen no matter what programming language you're using. All right. Thank you, everyone. And I do have these booklets too, which is like a checklist of different security, like file upload checklists, things like that. I've got a bunch of them here. Feel free to take one. And thank you, everybody.